No. Okay, good. Okay, so recording has started. Anyway, so if you cannot remember, I will talk about it. Okay. Let me start with a similar question first. Okay. So let's say you have two containers. Let's say you start with this container and you also have another container. All right. So let's say you have you already have some water inside this container. Let me make them of the same height. Okay, similar.
Oh, this question.
Last week, the question was not this, but anyway, this can be one of the questions. Okay, so okay, good. So let me start off. Okay, so the length for this, okay, this is called a container B. This is container A. Okay, so container A is empty. Container B is not empty. So container B has some water. Okay, has some water inside already. So let me give you the dimensions of each of these container. So over here, this is let's see, what is a good number? Yeah. Okay, let's say this is 10 cm, this is 5 cm, and this is 8 cm. Okay, then for this is 5 cm, this is 5 cm, and then this is 8 cm. Okay, so container A has these dimensions, and container B has these dimensions, and of course container B has some water inside already. Okay, so let's assume that
Here, is it water or just paper?
Paper. Well,
if it's water, then you'll go over here also.
yeah, I'm trying to complete it also. Yeah, thanks. Yeah, I'm trying to complete it. So okay, so let's say let's say here is let's say the water inside B is 1/8 of the height. Okay, so with this information, I think you can find out what is the volume of water already, right, in B. Okay, so what you do, so basically you just take length times breadth times height, and in this case the water inside B is actually 1/8 of the height. So basically the height is not 8, but you need to times 1/8 of it, right? So therefore it's 10 times the breadth is 5 and the h is 8. 1/8 of 8 is 1. So therefore you get 50 cm cube. Okay, so the volume of water in B is 50 cm cube. So far so good. Okay, now the question is, you have a tap A, you also have a tap B. Okay, so let's say your tap B is okay, then looks like I need to let me start with the same container first, because I don't want to make it complicated. I will make it complicated later on, but at the moment I don't want. So let's make it, we have the same container. So instead of 5 here, let's make it 10. So let's make it 10 as well. Okay, so you have the same container. Okay, container B, you have 50 cm cube of water inside already. Okay, you have already this. And then this one is empty. So now tab A, the rate of water going in is let's say 10 cm cube per minute. Okay, and then your tab B rate of water going in is actually 5 cm cube per minute. Okay, so what the question is going to ask you is how long does it take for them to reach the same height? Okay, so how long does it take for them to reach the same height? Okay, so what do you understand from the question? Or do you understand the question in the first place? Yeah, this is the question already. So do you understand? Do you understand the question?
Not really.
Okay, not really. So let me explain again. So what this question is about, right? So basically the question is
The rate question, right?
Pardon?
Rate question.
Rate, yes, it's a rate question. So the rate question, of course, the formula involved is this. The formula involved is rate is equals to the rate is equal to work done, okay, over time. Okay, so the formula involved is this formula, and of course over here work done is also the volume. Okay, to be more specific, so it's either work done or volume. In this case, it's volume. Okay, so volume over time is equal to rate. Okay, so the question now, this is the formula should be that is involved in this question. Okay, just think of it in terms of this formula. Okay, the question start with, so this container is empty, while this container already has some water. Over here is 50. Over here is 50 cm cube. Okay, so then you have both tab A and tab B, okay, of different rates of water going in. So what you will see, right? Okay, what you will see is, so basically you will see, let's say you have you have A, which is empty, and then you have a B, which is not empty. Okay, let me try to draw a similar one, which is not empty. And basically you are going to pump water inside of different rates. And what you will see is, you will start to see the water rise, the water level rise, until a point they will reach the same height. Okay, until they will reach the same height. So the question asks how long, okay, how long does it take for them both to reach the same height? So this is the meaning of the question. So how do you go about this question? So how long does it take for them both to reach the same height? If I come back to this question, probably they will reach this height. Okay, how long does it take then? Okay, how long does it take for them both to reach this height? What do you think? Hmm? Hmm? Hello,
I'm thinking.
you're thinking, okay. You want to attempt it somewhere on a piece of paper first? How?
I don't know. Leh.
You don't know. Okay, so let me get this onto the next page. Okay, let me get this question onto the next page. Okay, here it is. Okay, actually I can solve it using different methods. Okay, so later on I will let you choose which method you prefer. Okay, let me use the normal method that I think we have discussed before. Let me draw the table first. Nope, I don't want to delete the table. I just want to delete the. Oops.
Much cells.
Oh, never mind. I don't know what to do. Delete columns. Never mind lah. Just leave it. Okay, so you have your. I have.
So you know for the thing that you make,
Mm.
the thing that you use to make
Mm.
the column thing, you
Mm.
can actually make it to like
Choose the dimension, is it?
yeah. No,
I
the
know.
amount of boxes.
Yeah, exactly. But you know what I like to do? I always like to choose more than I need, so that it's good to cut down. Okay, it's harder to add. Yeah, that's why I choose more than I need. But anyway, thank you. So first, I have container A and container B, and this is called the initial volume. Okay, so for container, initial volume is 0. For B is 50 cm cube. Okay, good. Then over here, I write down the rates. Then of course, over here, I write down the time. And of course, here I will write down the volume. Looks like I need all of them. Oh, luckily I never delete any of them. So rate is for A is 10 cm cube per minute. Over here is 5 cm cube per minute. Okay. So after some time, right, you will get the volume. Okay. So this, okay, what's the relationship between rate, time, and volume? Okay, you refer to this formula here. Okay, so the relationship between these three, right? The relationship between these three, I call it the three parameters is this rate times the time is equal to the volume. Okay, so that's why I say this question, you make use of this formula. Okay, so bear this in mind. Or it can be work done also. But in this case, it's not work done now. Okay, in this case, it's volume. So I hope you know that after some time, actually, the question asks how long, right? The question asks how long. So that means the question is asking the time. Okay, so if the question asks for the time and we need to find the time, so let's say I assume after t minutes, okay, the volume of these two containers A and B will reach the same height, right? Same height means same volume. Am I right or not? Am I right or not?
Yeah, so 10 cm
So
square
basically you
times
get 10t. Okay. So over here you will get 5t, right? Am I right? But over here, the volume here, right? The volume here actually is the volume from taps. Okay. But I want you to differentiate one thing. This rate 10 times the time t, 10t is the volume from the taps. So, but the question here is for this tank A and tank B to reach the same height. So the volume of tank A comes from the tap, but the volume for the tank B comes from the tap plus. So basically, I have to add in one more volume. So this is called the final volume. Okay. Do you know why I need to add in the final volume? Because the final volume is the volume from the tap.
volume from the taps plus container B initial volume.
Correct. So therefore, the final volume here for the container A is 10t because it started with 0. Okay. But the final volume for container B is 5t plus the initial, which is 50. Okay. So the final volume has to be the same because both tanks, they are of the same dimensions. So what I need to do, so I just equate the final volume here. Does it make sense now? So I just equate them. So I have 10t plus 0 equals to 5t plus 50. So can you help me out? So what is the value for t? Can you help me out?
50 divided by 5 equals to equals to t.
So what's the value for t then?
50 divided by 5 equals to t, which equals to 10.
Okay, good. It's 10.
So 10t equals to 10 times 10, which is 100 minutes, which is
100 minutes.
1 hour 40 minutes.
Hold on. I thought just now what you said 5t equals to 50. So t equals to 10. So 10 minutes.
Yeah.
That's all.
Right.
That's all. Right? Right? Am I right or not? So that's how you can get the how long does it take for them to reach the same height? Same height means same volume basically. Okay, so 10 minutes. All right. So like I say, this is one way to get the answer. Okay, this is one way to get the answer. Okay, so what about the second method? Okay, so let me move on to the second method. So just now I make use of the each number total idea actually, if you cannot notice. So I'm going to use the second method and I will let you choose whichever method you prefer. Okay, so starting, A is empty. Okay, B has something. Okay, has 50 cm cube. So actually, right, that means B has 50 cm cube more than A. Okay, at the start. So what this means is, so let me give you one scenario, because in order to understand this method, right, I will say this method is much faster, but in order to understand this method, you need to understand the dynamic, or you need to understand the things involved. Okay, so let's say let me start with these two tanks. So B has 50 cm cube, and then this is empty. So this is A and B. Okay, so right now, the tap A rate is 10 cm cube per minute. Then this one is a 5 cm cube per minute. Okay, let's start. So after 1 minute, tank A will be 10 cm cube, right? Tank B will be 5 plus 50, right? Which is 55. Am I right? After 1 minute, tank A will have 10 cm cube, and then tank B will have 55 cm cube. Why? Because the 5 cm cube will add to the initial 50. Am I right? Let's move on to the second minute. So after the second minute, tank A will have 20 cm cube. Am I right? Then tank B will have plus another 5. So it's 60.
60 cm cube.
Yeah. So what I'm trying to say is, if, okay, of course you don't do it this way now. So you just go and like insert a table. Okay. It will make your life easier. So I'm going to insert a table, but this table is not a horizontal table. This table is going to be a vertical table. Okay. So let me just insert the table here. So this is A, then this is B. So this is after 1 minute. Then of course this is 2. Okay, I will just write the minutes here. Then I don't have to write the unit here. So after 1 minute, A will have 10, they will have 55, and then this will have 20, then this will have 60, right? Then of course you continue, right? Then over here is 30, then over here is 65, right? So of course you continue, and then once you continue, right, you realize that this table, if you continue, okay, you will realize that after 10 minutes, A will have the same volume as B. Do you agree with me? If not, can you help me fill up the table and see what is the final value here?
Wait, but I believe you.
Huh?
So why you want me to fill up the table if I already believe you?
No, you believe me, like, but I want to find a value, you know.
Can.
But 10 is the answer, but I don't know what is the value, you know. I also want to know the value. Why you believe me? Why you never go and check it out? Hey, you check it out.
Done. Correct.
Oh, okay.
100 to 100.
100. So basically, they will end up with 100 for both of them after 10 minutes. Am I right? Okay, good. So, okay, you believe, you believe. So so if you go and use this table, this method, this table, you can get the answer, but very slow. Am I right? Very slow. Okay. Why? Because the answer is 10 minutes here. right? So you must be thinking, what about the answer can be what? 1000. Are you going to list 1000? Are you going to list 1000 rows down? No, right?
No, there's a easier way.
Yeah, okay.
10 times 1000 and then
Mm-hmm.
10 times 1000
Mm-hmm.
10 times 1000 and then
Mhm.
5 times 1000 plus 50.
Yeah, okay. So now you already know it. That means basically you know the dynamic behind. Then you say, oh, just times the 10. 10 times the 1000. Okay. Because now you already know the dynamic behind. It means basically you know what is happening behind. But what if you don't, right? So in fact, you don't have to look at this question. You can of course use this table. You can you can list them down, but it's going to take you a lot of time. So there is a easier understanding here to get this question. Okay, so let me get this slide to this. Okay, it's important to know this question. Okay, I already explained to Nancy, so I hope you also get this question. Okay, so the dynamic here is this. Okay, so I hope you can see that the difference between these two at the start is 50 cm cube. Okay, this is the difference at the start. Okay, and if you look at the rate, okay, if you look at the rate, tab A is 10, tab B is C. So that means for each minute, okay, tab A is going to catch up 5 cm cube. Okay, so for each minute, right, tab A is going to catch up 5 cm cube. So basically, in order to catch up 50 cm cube, because this is the difference, running out of time. What's this? Remove the. Okay, so later on, if my Zoom runs out of time, we just restart the video. Okay, but anyway, never mind. Continue first. So if I have 50 cm cube difference for this tab A to catch up, right? Each minute tab A is going to catch up 5 cm cube. So easy, no? I make use of this. I make use of this idea here. This is the key idea. 1 minute, I catch up 5 cm cube. 2 minutes, I'm going to catch up 10 cm cube. So that means how many minutes I can catch up 50 cm cube? And then the answer is 10. Okay?
Okay, understood.
That's how you can get 10. All right? That's how you can get 10. So if I change the question, let's say the question is the difference at the start is actually 100 cm cube. Okay? The difference at the start is 100 cm cube. And now tab A, the rate is 100 cm cube. Tab B, okay, the rate is 95 cm cube. So how long does it take for them to reach the same height? So what you need to do, you know that each minute, tab A is going to catch up 5 cm cube per minute, right? Okay, so it means after 1 minute, you catch up 5 cm cube. So after 2 minutes, you catch up 10 cm cube. So basically, in order to catch up 100 cm cube, your time is 100 divided by the 5, which is 20 minutes. Okay, so does this method prove to be easier?
Okay lah.
So I think this method is much easier than the one just now. Here. Okay, but of course you can use this. You can use this method also. Okay, so please remember these both methods. Okay, so this is the volume question. Okay, I'm going to demonstrate to you a similar question from last week. Okay, last week is here. Is Jingxuan. No, you're not Jingxuan, right? You are not Jingxuan, right? So last week.
Why would my name be Jing Xuan?
Yeah, last week is Ai Tong, right? Last week your paper is Ai Tong, right? Yeah.
I think so.
Okay, let me open Ai Tong. Ah, this is the one. Okay.
Last week people was Singapore Chinese.
Oh, never mind. But I want to talk about this question. Jacob and Kumar is okay. It's Chinese. Let me see. Let me double check. Ai Tong. Never mind. Probably you have done 2 papers. Okay. But anyway, I want to talk about Ai Tong. The last question.
Yeah.
I mean previous week lah, not previous week. Okay. So I want to talk about this question. If you can remember, if you can remember, is good. If you can't remember, never mind. Just look at the screen here. Where's my question 16?
Scroll to the bottom. Yeah.
Actually, I did. Never mind. I don't know. Funny, oh. Where's the question, oh?
Maybe it's at the very top.
Here. Sorry. Okay, here. Okay, so let me just get this question out to the PowerPoint. Yeah. So I'm going to make use of the first method to solve this. Done. Drag it to here.
Teacher, why does it say time left at the top?
It says I'm not using the paid version, so I have time limit. But anyway, never mind. So later we just restart. Okay, never mind. Let's continue first. So when I go offline, then we just come back on. Okay, never mind. I start with this first. Okay, so this question says Jacob and Kumar needed bottle cap for a project. And then Jacob has 633 bottle caps and Kumar had 242. So that means they both start with the something. So I'm going to insert a table first. Maybe I just make use of this table, but change the headings. Okay, I just use this table, but I change the heading. So over here is a different name only, Jacob and Kumar. So I want you to see the similarity between these two. This is initial caps. So Jacob is 633, and this one is 242. Okay, and then it says every week. So basically, this is the rate. So basically, the rate I change it to caps per week. Okay, so every week Jacob will collect 35. So 35. Kumar is 58. Okay, so it says how many weeks would it take for the both of them to have the same number, right? Yep. So the time is still the T, but over here I need to change to caps from collection. Okay, then this is of course the final caps, right? So the caps from collection here is 35T.
And 58T.
Below is 58T. And then of course the final cap is 35T plus 633. Correct.
Then 58T plus 24.
Exactly. 242. Right? And then after that, what you're going to do, you're going to form an equation. So the equation is, because they say what? How many weeks would it take for both of them?
5T plus 633 equals to 58T plus 242.
Very good. Can you help me solve this question? To find out what is T? Yep. Can you tell me what is T?
T is 17.
Oh, good. Okay. So after 17 weeks, both of them will reach the same number of caps. Okay. So this is one way of doing the question, right? Let me demonstrate to you. You can actually remember the answer is 17 here. So let me demonstrate to you. You can actually make use of the second method. Okay. What is the second method? The second method is not this table. The second method is not this table. The second method is, first thing first, I want to find out what is the difference between them at the start first. So the difference between them at the start is
The
633.
difference is 633 minus 242, which is 391.
Wow, how come you are so fast? Okay, so
I already did it.
okay, so this is the difference at the start. Then you want to find out after each week, right? How many Kuma 58. So Jacob is 35. So that means that each week Kuma is going to catch up 58 minus 35. 23, right? Yeah. So each week Kuma is going to catch up 23. So basically 1 week Kuma can catch up 23. 2 weeks can catch up 46. So that means after how many weeks Kuma can catch up this 391. So the question mark is equal to 391 divided by the 23. Can you help me check it out if you can get 17 also? Actually, I can launch my calculator.
I'm trying to mental calculate,
Ah,
but I don't think I can do it.
yeah. Okay, yeah, the answer is 17. I just did it. Okay, so yeah, basically you can also do it this way. Okay, let me just log off and let me log in again. Okay.
Less than a minute.
Yeah, let me just log off and quickly log in again. Okay, can give me a less than 1 minute. Okay, stop sharing. Good. Log off, log in again. Bye bye. See you quick.